sign up with me for elk time so we can go through a practice test. Alrighty, look at that. It's a lovely table. But I didn't label it anything because I just made it up. So I didn't have any labels. It says, using linear regression, write an equation to model the table above. Use a 0 for the year of 2000. So if I'm using 0 for 2000, what should I use for 2005? 5. So this will be a 5, 6, 7, 8, and 9, and that'll go in list 1. And then all of this good stuff here, that's list 2. So, that calculator, remind me again how to get this stuff in there. Stat, edit. Okay, so stat, right there. Number 1, and yeah, I cheated because, you know, I had the other class before you guys. So I've got mine in already. Let me move this out of the way so you can see the numbers. Punch them in yourself. So list 1. Oh, do you remember how to clear the list? Because you probably have some stuff in there. Go all the way up to the top of the list where it says L1, hit clear and enter. And then we'll take all that good stuff off. Okay? So go ahead and put those in. Anybody need more time to get the numbers in? Well, one of the things that I see down below here as I start to think, well, what do they want me to do for the whole problem, because it's got an A, B, and a C, is describe the correlation. Correlation. Correlation is that little R thing we get on the calculator. But, especially those people that just borrowed my calculators, the memory's been cleared, so your diagnostics were turned off. You remember what we do on the calculator to get the diagnostics turned on so that we can get our little R, the correlation coefficient. You have to go into the catalog. Take a look, see if you can remember where the catalog is. Second, 0. Look at what's going on the 0 button there. Got catalog in blue. So second, 0. Now this is what takes the time. You have to scroll all the way down to diagnostics on. And then you hit enter twice. And mine's already on, and I'm not going to miss the time to do that. So all the way down to diagnostics on, hit enter twice. Okay. So far you haven't remembered much about this, which is a good thing we're going over it. But we want the calculator to give us a line of best fit. Where do we go? Yeah. Good. Stats. Calculate. Right there. Right arrow. Which one of those? Number 4, linear regression. So you either hit 4, or you can scroll down and then hit enter. We just want to go all the way down to calculate here, because we've got list 1 and list 2 in there, which is great. And I want it to give me that line of best fit. So there it is. And when I get to the other page here, I will write down y equals 36.5x plus 0.1. So stats, calculate, number 4, linear regression. But I saw that B was, how good a fit is it? I mean, that's what correlation means. Remind me again, what's a perfect R value? 1 or negative 1 if it's a negative correlation. That's pretty doggone close, because that's about 0.9 if we round that. So that's a pretty good R value. So next thing would be, all right, I know it's a strong relationship. It's not weak. This is a big number. It's close to 1. So it's a strong relationship. Is it positive or is it negative? You get that from the slope. The slope is positive. So this is a strong, positive correlation. The slope is what's going to tell us, hey, is this going up or is it going down? So let's go back and see what else we're supposed to do here. So we've got our equation, y equals 36.5x plus 0.1. It asks us, describe the correlation, and we said this one is strong and positive. So let's not forget what could happen. It could be strong or weak. It could be positive or negative. Or you might see no correlation. There might be points all over the place. But if it's going to be on the test, chances are pretty good it's not going to be no correlation because we want you to be able to find this stuff. So now C says, now that you have this wonderful formula, and you know that it's a strong positive correlation, can you predict what's going to happen in the year 2017 from this information? Well, what would you put in for X? 17. Exactly. Because remember, we said the 0 year was 2000. So it'll be Y equals 36.5 times 17 plus 0.1. And go ahead and punch that in. It'll be a lot faster for you guys to do it. Have it already? What is it? That's what it is. So there's our prediction. Right there. That's it. Now, might be a little messier on the test. And what I mean by that is you might have to go like 3 decimal places or something because this one worked out really nice. I mean, it's pretty rare that we end up being able to go tens. Stats, arrow to the right once, so it goes to calculate. Let me show you. Here I am standing here trying to explain it. So stat, and then arrow to the right once for calculate, and it's number 4. So you either just hit number 4. Some people like to use their arrow buttons to go down to number 4 and then select it. It'll find it for you either way. And then all the way down to calculate. And it'll give it to you. But again, your diagnostics have to be turned on so you can see R. It won't, but with this problem, we're not necessarily going to have to see the scatter plot because we can know from the slope whether or not it's positive or negative, and if we see R, we're going to know whether or not it's strong or not. So I guess the question most people ask is, what's kind of the cutoff for strong versus weak? I mean, if one is perfect, when should you start saying maybe this is weak? I would really say anything more than 0.7 is probably weak. 0.7 and above is fairly strong, but anything below that is a really weak relationship. And that's the scatter plots. Again, you won't have to do that on the test, but if you want that, you have to do second and Y equals. And then you have to go in and turn it on. And you have to change your window so that it fits the numbers that we put in for X and Y. And this one is. So you can see it. And maybe that would be helpful too if you're having trouble figuring out if it's positive or negative correlation. Again, just the slope should be enough. Because if the slope is positive correlation. If it's negative. Everybody going to be able to do that on Monday? No problem, right? No sweat. Got it. It's all good. Okay. Now I'm going to turn that little puppy off because my computer does not like all this on at one time. And we will go back to what you guys were super good at, which is our graphing absolute value. You know, today we're not going to focus so much on graphing as what are the numbers telling us, and then how would we graph if we were going to. So, wowie gazowie, look at that. Well, it's just putting everything together. You know, this is where we say A. Okay, if there's a number in front and it's bigger than 1, then it's a vertical stretch. If it's a fraction between 0 and 1 plus u, then it's going to be a compression. If there's a negative, it's a reflection over the x-axis. So there's a lot of information that we get just from the number in front of the absolute value bars. And then h, that's the biggie. We have to remember it's always backwards from what we think. So if we see x minus 2, that means it's going to the right. If we see x plus 3, that means it's going to the left. If anybody misses anything on this test, that's usually it. So watch out for thinking backwards whenever it's connected to x. But k, very straightforward. If it's plus, it goes up. If it's minus, it goes down. So the things that really take the most work thinking-wise here would be all the things that A tells us, and then h backwards, always remembering backwards. So a stretch or compression, we take a look at the factor of the absolute value of A. What is up with that? There's no absolute value. it's negative or positive when we're trying to figure out if it's a stretch or a compression. For a stretch or a compression, we're just looking at the number, the numerical value, and saying, hey, if it's a number bigger than 1, it's a vertical stretch. If it's a fraction between 0 and 1, then it's going to be a compression. And, as we found out yesterday, this H and K give us our new vertex. They give us the new starting place. The original starting place is at 0, 0. But then we're going to move it H and K units. And then last but not least, we talked about a line of symmetry yesterday, but what we didn't do was actually write it. And today we're going to do that. We're going to write down, hey, this is the equation for the axis of symmetry. This is where you fold this picture over and get the same thing on both sides for your V. That is always going to be a vertical line. So we're always going to write x equals. And then you think, well, what does x equal? Well, just look at the vertex. Whatever your x is right here. Because your axis of symmetry has to shoot right through that vertex. So it's x equals whatever your x coordinate of your vertex is. There it is. So, we're writing new examples of it. Yeah. Compare y equals negative 2 times the absolute value of the quantity x plus 2 plus 3 with the parent function. Without graphing, answer all this gunk. So what I do first is I think, okay, you got to think this way. And think about what are A, H, and K, and what are all the things they do. And the first thing they ask me for is the vertex. And the vertex is H and K, because that's what moves it right or left, up or down from 0, 0. So this one's not at 0, 0 anymore. What are the coordinates for this vertex? Carefully. Good, negative 2, 3. Yeah, because we always have to take the opposite of whatever we see in those grouping symbols. In this case, absolute value. So the axis of symmetry, well, that's not going to be tough. Because it's a line, and it's a vertical line, it's going to be x equals something. Well, then just go up here and ask yourself, which one of these is x? Negative 2. Done. Now, warning. People forget that. Because it's too easy. You know, you start looking all over the place. X equals, what are they talking about? Where does x equal? Well, there's an x right there. Don't overthink it. Right there. And then transformations of the parent function. Okay, well, there's a lot of them. But we go left to right. So I've got my little negative here, and I've got the 2, and I can do either one of those first. I think I'm going to do a vertical stretch factor of 2. Then I have to think, well, what was a negative for? Why is that out there? What is that? Reflects it over the x-axis. So reflect over the x-axis. Now those can be done in any order. So if you're thinking, okay, theorem is left to right, then we dealt with the 2 first. It doesn't matter. You could do the negative first. You could say reflect over the x-axis. Then vertical stretch factor of 2. Same thing. Now we got to deal with this. What's that doing? 2 to the left. So translate 2 to the left. Translate 2 units left. And we have one more to go. What's the plus 3 doing in the back? Up 3. So translate 2 units left and up 3. Those are both translations. We can reinforce together. As long as you keep those one together. Cool. So all that just from seeing what we have up there. Now, if we were going to graph this one, didn't ask us to. If we were going to graph this one, we would do exactly what we talked about yesterday, which is go to that new vertex, negative 2, 3. So negative 2, 1, 2, 3. Right there. And then you use the slope to figure out where your V is. And the slope is always 8. So if my slope is negative 2 from that spot, I'm going to go down 2 and to the right 1. Down 2, right 1, down 2, right 1. And there's the right side of the V. And then for the other one, I can go down 2 and left 1. Like so. So when you do graphing today, it's the same as what we did yesterday. It is. You just have to find that new vertex first and and then use your slope. So this one says, what are the vertex and axis of symmetry of this bugger and how is it transformed? Yeah, it looks different, but it's the exact same stuff we just did in the last problem. So let's do this first. And then we'll find the vertex. Where is our new vertex? Where's our new vertex? 1, -3. H and K. And I'm not going to write out axis of symmetry because I'm a math gal. I'm going to put A dot O dot S dot. Always vertical. So what does that mean? X equals, it has to be X equals. That's vertical lines. Vertical lines all karate chop the X axis. X equals what? Just look up here. It's a 1. There it is. And now we just have to describe those transformations from left to right. Well, the -2 out in front is kind of silly because that's the exact same thing we had on the last one. But what does it mean? Vertical stretch, factor of 2. And it's a -2. Reflect over the x-axis. All right, so we've got our little -2 out front here. What's this doing here? 1 to the right, exactly. So translate 1 unit right. Oops, I flipped that up too far. And down 3. Is that right, everybody? Down 3. You got it. There's all 4 parts. Then we talked about A. Okay, that's a vertical stretch because it's bigger than 1. The negative, hey, that came from a reflection over the x-axis. And then this was opposite of what we see. 1 to the right and down 3. And we've got it. So again, we want to be able to describe it, not just graph it. But graphing, you have to be able to do well. So this says, we're going to discuss this because this is weird. If y equals a, absolute value of x minus h plus k is the transformation of the parent function, y equals the absolute value of x, how could you graph the following? I don't know. Because this is right here. It's not allowed to be there. It has to be out in front. Okay? So then I think, well, how could I get it to be out in front? I mean, normally, wouldn't we just factor that out? Divide it out and factor it? Okay, let's give it a try. But it has absolute value bars. And if you're going to divide absolute value, you have to divide out an absolute value. -2 times x would give you -2x, and -2 times -3 would give you +6. So the question is that legal? In math, is that allowed? It is. Yeah, it is. Just like we can take square roots times other square roots, cube roots times other cube roots. You take an absolute value times another absolute value, or you can pull it out by dividing. Do we know what the absolute value of -2 is? What is it? It's 2. Now it looks like it's supposed to. That's what we needed. That x was supposed to be right after the absolute value bars. That's what this does. So we had to get this to look like that. Now it does. So now, when they ask us how would we graph this, well, the first place we'd go is the vertex. So step 1 would be, hey, where is our new vertex? Where is it? a negative 4. And then we would use a as the slope of the right side of the graph. So use m equals 2 for the right side of the graph. Now we do need to say something about the left side. How many of you have been using symmetry to graph the left side? Okay, so a couple of people saying, yes, I did that. How many people are using slope backwards? Yeah. So for most of us, we'd write, then use the slope backwards and graph the left side. Then use slope backwards to graph the left side. They didn't ask us to graph it, they asked us how would you graph it. We'll find your new vertex. Use A as the slope of the right side, and then graph that slope backwards. Get the left side. We've got it. So now we have this one. They want us to write an absolute value function. They do. And you know what? It's not hard. Because all we have to do is come up with 3 numbers, A, H, and K. And A is the slope of the right side of the graph. And H and K is the vertex. So identify the vertex. What is it? There it is. And that is H and K. A, well, we'll count. But remember, right side of the graph. So we want to know, how do you get from there? That's a nice good point right there. So from left to right, how do you get from this point up here to this point down here? Down 1 and over 3. That's A. Hey, should it be negative? How do you know from the drawing it's supposed to be negative? It's going down. It's going down. Well, we're already at right the equation. How can we be that ready? Let's see. We need y equals A. Did we find A? Negative 1/3. Absolute value. Now we have to be careful. X minus a negative 1. So what's it going to say? X plus 1. And then what do we put in the back? That's not a big deal. Probably the hardest thing to do is to remember to make the X coordinate for the H backwards of what you see, you know? Or maybe some of you have a little trouble counting slope visually. That might have been the hardest part of this, but I'm guessing this is not going to be incredibly difficult for you. So here's what I need you to do. I need you to do the got it. You'll be done probably by the time I even figure out the candy bag. But I'll bring the candy around. We'll get you a partner so you can check with somebody. Make sure you're doing this stuff right. Alrighty, looked like a lot of people were done by the time I got to them. So, candy up in the air, make eye contact, get out of your seat, take your packet and something to write with, and go talk to that candy partner, see if they got the same thing you did. Oh, Pablo? Right at the front of your row. Makes it kind of hard to see. Anybody else not finding their candy partner? Okay, check and see if you get the same stuff. Yeah.
Let's open the right side. So the right side always supposed to stay. Taylor.
Hang on, let me get around the room here.
Oh, it's hilarious.
You need to talk to each other because a couple of you did your x minus h and you forgot to go backwards. Remember, it's always the opposite.
Yeah, it's like, wait, I'm wrong. Oh, yeah, you are. You're wrong.
All right, let's talk about it so that everybody can know either they're right or their partner's right on this one. Okay, first off, some of you had a little trouble counting A. Here's why. A is always the slope of just the right side of the graph, not the left side. A is the slope of the right side. So to go from here to here, you'd have to go up 1 and over 4. So A is 1/4. Now your vertex is at 2, -1. So you start putting it all together and you realize, well, it's going to be y equals, yeah, I suppose we better name it y equals 1/4 absolute value. And you remember, okay, wait a second. It's got to be x minus whatever that h is. So it has to be x minus 2. But the number in back is just whatever it is. Because up is plus and down is minus. So there it is. So 1/4 absolute value of x minus 2 minus 1. 4, 3, 2, 1, 0. Not just graphing, but writing and all of that good stuff. I know our objective is just the graphing. But if you made a mistake and it was a little one, did you feel you could fix it? Good. Excellent. Well, thank you, partners, for their wonderful conversation. And again,
have.